Okay, hello everybody. Today I'm going to show you how to dimension the stair systems. Firstly, let's remember a couple of terms. The first term is step. You remember it, it's the horizontal plane in a stair system. And the second term that you need to know is riser. Riser is the vertical plane in a stair system. Okay? And you know a stair system connects two floors, two different levels to each other. That's why they connect these two different levels to each other with a slope. Okay, and the slope of the stair system is important for ease of use. That's why what we need to do, we need to keep the slope of a stair system something around 56%. Okay, the easiest to use stair system needs to have a slope of 56%. But of course this 56% cannot be achieved in all of the design jobs because the clearance of the buildings, the clearance of the stories of a building is not determined according to the number of risers. It's determined according to the wishes of the client and also the architect. And that's why what we need to know is how to calculate the width of a step and the height of a riser. And we do that with a formula. The formula tells us that 2 multiplied by step width plus riser height needs to be something equal to 64 centimeters. Where does this 64 centimeters comes from? If you wonder that, it is the approximate dimension of a step of a human being. Okay? Now let's try to understand how to use this formula. First of all, let's simplify that formula to S plus R is equal to something like 64 centimeters. Okay? So let's now assume that we have a building like this. Okay? And we have got 3 floors. Okay? This is ground level, this is first floor level, and this is second floor level. And let's also assume that the ground floor of the building has a clearance of 2.8 meters, whereas the others are all 3.1 meters. Okay? What we need to do is, firstly, we need to convert these meters into centimeters. The clearance of the ground floor is 280 meters, 80 centimeters. The first floor has a clearance of 310 centimeters, and the second floor also has a clearance of 310 centimeters. What we need to do at this point, we need to remember that different function of buildings have different appropriate riser heights. What do I try to mean? In a normal residential building, the approximate riser height in a residential building is not exactly but approximately 17 centimeters. Okay, the riser height of a school or of a hospital building is something around 16 centimeters. We have talked about it during the lecture. In schools, the main users are small children, and in hospitals, the main users are sick people. That's why, in order to ease their job while they are using the stair system, we need to decrease the approximate riser height. Okay, in an outdoor stair system, okay, outdoor stairs, we may decrease this appropriate riser height to something around 15 centimeters. Okay, you know, we have got a specific type of building in social governed countries. Governments construct social housing buildings. Okay, in these social housing buildings, the main aim is constructing more with less money. That's why decreasing the stair size is going to decrease the costs. For that reason, what we can do, we can increase the riser height to something around 18 centimeters. Okay, and we also have told that the riser heights are very rarely full numbers. They are usually decimals. Because once more I want to remind you that we do not determine the clearance of a story of a building according to the riser heights. We do not say that we are going to construct here a building which its floors are connected to each other with 20 steps, and each step is, or each riser is 16. So let's make the clearance of this story to 3.2 meters. We do not do it that way. What we do, we say that let's make the story height 2.8 meters. Let's make it 3 meters. Let's make it 4 meters, for example. Okay, we do that without thinking about the risers usually. Okay, what we need to do then, okay, we have a building like this with the clearance of these. What we need to do, we need to look at the function of the building, and let's assume that we are working on a residential building. What we need to do is, firstly, we need to divide this 280 centimeters. Let's start with the ground floor of this building. Okay, what we will do, let's write it here, clearance of ground level, let's say, but and the building is a residential building. So what we will do, we are going to divide the clearance to the approximate riser height. Okay, this calculation is going to give us the number of risers, which have to be a full number. Okay, let's do it. The clearance is 280 centimeters. The approximate riser height is 17 because we are working on a residential building, let's say. Okay, what we need to do, we need to divide 280 to 17. Okay, it will be something around, oh, we can make it a 6, sorry. Okay, 42, this is 42. Okay. Okay, so it will be something around 16.4 something. Okay, but don't forget that it needs to be a full number, so we cannot leave it as a decimal. We need to choose the one of the most nearest full numbers. Okay, so the number of risers of our building will be either 16 or 17. Now you need to choose. Okay, if you choose 17, there will be more risers. That's why the riser height is going to decrease, which is also going to decrease the slope of the stair as well. If you choose 16, there will be less number of risers, which is going to increase the riser height of each riser and also going to increase the slope of the stair. Here I will choose 16, let's say. Okay, let's make a more steep stair. Okay, now that we have chosen 16, I want you to write what that represents. Okay, I want you to write that this is number of risers. If in an exam or in a quiz I ask you to make this type of a calculation, I want you to write it like this. Okay, now that we know the number of risers, what we need to do, we need to exactly calculate the riser height. Okay, in order to do that, we are going to redivide 280 to 16. This time this 16 comes from here. Okay, it is the number of risers. Okay, so it will be so this I want you to put in a circle like that, and I want you to write that this is the riser height. Okay, so our riser height is 17.5, which is a good decimal to measure. Sometimes you will see that it will be something around 17, 4, 5, 6, 3. It goes on like that, okay, which is an irrational number. In that case, what you need to do, you need to keep in mind that in the construction site, the most precise calculation in a normal construction site, you can only measure millimeters, okay, which is going to be represented with the first digit after the comma. So in the exam or in your real life, if you make this calculation, what you need to do, you need to say that the riser height is approximately 17.4. Okay, one digit after the comma will be alright. You may ask me or yourself, if we do not use that irrational number, the stair, how is it going to really catch up this 280? In the construction site, you measure with a tape measure. You remember that? So one step will be maybe going to be all the risers will be tried to be made 17.4, but it is almost impossible to measure it exactly 17.4. Okay, so it will be rounded up itself. Okay, so we already calculated the riser height, the number of risers. What about the steps then? What you need to do, you need to use your formula. Let's write it here again. Okay, sorry, I made a mistake. Okay, we will need to erase this and write riser height here. Okay, and step width there. Okay, so 2r plus s will be something around 64 centimeters. That was the rule. Okay, let's correct this as well. Okay, which means that our riser height is 17.5. 2 multiplied by 17.5 plus step width needs to be equal something around 64 centimeters. So s will be around 64 minus 35, which is the solution of this 2 multiplied by 17.5. So the step width will be equal to something around 29 centimeters. Okay, I want you to put it in a circle and write that this is the step width. Okay, sometimes you will see that the step width will not be a full number like this. Okay, it can be a decimal. If this was 17.4, it's going to be something around 29.2. But for steps, you do not necessarily make it or dimension it as a decimal. What you may do, you can just round it up to the most nearest full number. Okay, now we are about to finish. But what we need to do, we need to design the form of our stair as well. Let's put these sheets here. Okay. So now what shape of a stair would you like to make? Okay. Let's categorize the stairs according to their forms. Straight flight stairs. Okay. What else do we have? Straight flight stairs. Curvilinear stairs. Excuse me. Curvilinear or half spiral stairs. Half spiral flight stairs and spiral flight stairs we have. Okay, and also what do we do from the lecture? Probably you will remember that we can use the number of flights to give a different design, different shape, different form to our stair. So 1 flight, 2 flight, 3 flight, and goes on like that. Number of flights. Okay. Also, we can give different relations or different directions to our flight. U turning or L turning stairs we have. Okay. So let's assume that this stair system is wanted to be a straight flight, straight 2 flight U-turning stair. Okay, so what I want you to do, I want you to draw it firstly. Okay, so firstly let's assume that it is U-turning, there are 2 flights and it's a straight flight stair. Okay, what you need to do, you need to firstly draw a sketch like this. Okay, so what do we have? We have our flights here, first flight and second flight, and we have the mid landing here. And what do we have? We have the start landing here. Okay, so firstly you know the minimum width of landings, don't you? The minimum width of landing needs to be equal to the flight width or stair width. Okay, so we need to remember the stair widths now. The stair width for a normal residential building needs to be something around 120 or 25 centimeters. Okay, which means that we know this dimension. It is 125 centimeters. The other flight is also going to be 125. And we know, you know from the lecture, that the minimum width for a landing needs to be equal with the, at least equal with the stair width. Okay, which means that we also know these 2 dimensions as well. What we also know that the step width is 29. Let's write it here again. Step width equal to 29 centimeters. And we also know that we have a total number of 26 risers. Number of risers will be 16. So 8 of those risers will be here and 8 of them will be there. Okay. So what will we do? Firstly, a small new information. The number of steps is always one less than the number of risers. What do I try to mean? Let's draw a schematical section here. Okay. Here is the start landing, here is the mid or end landing. Okay, and this is the section drawing. And right on top of it, I'm going to draw the plan of it. Okay, so let's count the number of risers. This is riser 1, riser 2, riser 3, and riser 4. Let's count the steps. First step, second step, and third step. What about the fourth one? Fourth one is not a step, it's a landing. What about here? It is not a step as well, it is also a landing. Okay, so let's write landing here. Let's write landing there. And let's write the number of steps here. Okay, so as you see in this small sketch, we have got a stair of 4 risers, whereas the number of steps is one less than it. Okay, riser number 4, step number 3. Similarly, as this is going to be a U-turn stair, what you need to do, you need to put half of those risers to one flight of it and the other half will be placed to the other flight of it, which means that in each flight we are going to have risers of 8, which means also that in each flight we are going to have 7 steps. Okay, let's draw it. 1, 2, 3, 4, 5, 6. Okay, first 1, 2, 3, 4, 5, 6, and 7. Okay, and we are going to have the same thing here also. Okay, now let's put our walking line. You remember we need to put a walking line like that. Here is its arrow. Okay, and on top of the walking line, let's write the number of risers. First riser is this one. Second riser is that one. Third riser. Fourth riser. Fifth riser. Sixth riser. Seventh riser. Okay, in the plan, we count the number of risers, and this is landing. But this line is indicating a riser. That's why we need to write 8 there as well. Similarly, this is the 9th, 10th, 11th, 12th, 13th, 14th, 15th, and 16th risers. Okay, we are finished with that. But what were we trying to find out? We were trying to find out this length, the length of the flight. There are, as you see, 1, 2, 3, 4, 5, 6, 7 steps. So in order to calculate this size, we need to multiply 7 steps. Each step is 29. It will be equal to, just a second, I couldn't multiply it that way. Okay, this is 203 centimeters. So our stair has a staircase dimension of 125, 203, 125, a total of 453, and we have a width of 250, 125 on each flight. So the staircase dimension will be equal to 250 to 453. What else can we find? Do we forget anything? We have calculated the staircase dimension. We have calculated the total number of steps in each flight. We have calculated the total number of risers in each flight. We have calculated the total risers in the stair. We also calculated the step width, stair width. We have calculated everything. We even calculated the size of each flight of this stair. Okay, so if you are asked to write down the size of one flight of this stair, it will be flight size. Let's say the flight has a length of 203 and a width of 125. Okay, so we have calculated everything about our stair. Okay, why not you now try to calculate or dimension a stair system for the first level of the building, which has a clearance of 310 and which belongs to a school building. Okay, let's write the question here. Design a stair system for a school building that has a clearance of 310 centimeters. The stair is wanted to be a 2-flight L-turn straight stair. Okay, so let me put the question this way. Okay, so until next Monday, please find all the dimensions related with this stair system. Let's write what I want you to find here as well. I want you to find the number of risers. I want you to find riser height. I want you to find step width. I want you to find number of risers for each flight. I want you to write the number of steps for each flight. I want you to find out the staircase dimensions, and that's all, I guess. Okay, so in a couple of sheets like I do, and of course I want you to draw a schematic plan of the stair. Okay, see you later. Bye bye.